Hello class, I hope you find this video in the best of your health. Today I will teach you critical path method. Before teaching you the whole method, there are certain terminologies which I'll teach you using an example. So this is an example of a project. It has 6 activities. The duration and the precedence of the activities are given. I've made a Gantt chart to represent this project. So if you observe the Gantt chart, activity A, if it is delayed, say by 1 or 2 weeks, the whole duration of the project is going to get delayed. But if you observe activity B, if it is delayed by say 1 or 2 weeks, it is not going to affect the total duration of the project. So what it means is activity A is a critical activity, while activity B is a non-critical activity. Similarly, activities C, D, E and F are critical activities. So now we'll understand what float or slack is. So it is the amount of time a task can be delayed. So the float for activity B is 2 weeks, while float for activity A, C, D, E and F is 0. Now we'll understand what path means. So this is a project network. If you observe the project network, there are 2 paths. Path is basically a sequence of activities joining the first event and the last event. So you can see there are 2 paths in this whole network. So how you will represent the path? A, C, E will be one path. B, D, E will be the second path. Now you can also represent this using events. So you can represent this path as 1, 2, 4, 5, and you can represent this path as 1, 3, 4 and 5. So now to do project network analysis, there are certain prerequisites which are required. The first is the duration of each activity. The second is to know the precedence of each of the activity. Using duration and precedence, we can automatically make a project network. And the third and the most important is to know the start time and the finish time, which is extremely helpful for the project network analysis. So every activity will have a start time and a finish time. And again, a start time will be the earliest start time, the latest start time. Finish time will have the earliest finish time and the latest finish time. So what it really means is the time for an activity to start as soon as possible. It is also represented as EST. Latest start time is the time for an activity to start as late as possible. It can be represented as LST. EFT is the time for an activity to finish as early as possible. It can be represented as EFT. And latest finish time is the time for an activity to finish as late as possible. So it is LFT. Similarly, for an event, there are two times. First is the earliest occurrence time, and the second is the latest occurrence time. So now basically what it means is without affecting the total project duration, how late or how early you can start or finish a project. This is represented by E and this is represented by L. Now we'll see how do we calculate the value of E, then we'll see how to calculate the value of L, and then how E and L are associated with EST, LST, EFT and LFT. So now we'll see how to calculate E for any event. We need to work this out with 2 assumptions. The first is that every event will start with 0 time. I'll come up with the second assumption as we proceed. Now to calculate the E for the second event, you need to add the duration of the previous activity plus the E for the previous event. So 0 plus 2 will give you 2. Similarly, for the third event, the value of E is 0 plus 3, that is 3. Now if you observe the fourth event, it's a merging event where two different activities are merging into this event. So for this you need to take the maximum value for E. So E from this activity is 4 and E from this activity is 5. You need to take the bigger value, so we'll take it 5. E for fifth will be 6 plus 5, that is 11. E for sixth will be 2 plus 5, that is 7. Now E for the seventh event will be either 7 plus 1, that is 8, or 11 plus 3, that is 14. So you need to take the bigger value, 14. Now it's going to we have calculated the value of E for this network. Now we will calculate the L for any event. For this you need to use the backward pass method. So the backward pass method has to be started from behind. Our second assumption is that the value of E and the value of L for the final event is going to be the same. So we take this as 14. Now L for the event 5 is 14 minus 3, that is 11. You need to subtract the duration from the previous L. Now the L for the event 6 is 14 minus 1, that is 13. Now again, if you observe the fourth event, it's a bursting event where two different activities are going out of this event. So you need to take the minimum value for this. So L for event 4 is 11 minus 6, that is either 5, or it could be 13 minus 2, that is 11. So you need to take the smaller value, that is 5. For event 3, 5 minus 2, that is either 3, that is 3. For 2 it is 5 minus 2, that is 3. For the first event, 3 minus 2, either it is 1 or it is 3 minus 3, that is 0. So you need to take the smaller L value, that is 0. Now we will see the relationship of EST, EFT, LST, LFT with E and L. So we have calculated E and L for each of these events. Now EST is the earliest start time for any activity. EST, EFT, LST, LFT are associated with activities, while E and L are associated with events. So now I am representing EST, EFT, LST, LFT in this way. What it means is the earliest start time for this activity will be 0. The latest start time for this activity will be 0. The earliest finish time for this activity will be 2. And the latest finish time for this activity will be 2. Similarly, EST, EFT, LST, LFT for the activity B is 2, 2, 5, 5. Now we will go through the various steps involved in the critical path method. The first step to determine the critical path method is the forward pass. Using forward pass, you will get the value of E. The second step is to go through the method of backward pass. You will get the value of L for this. The third step is to calculate slack or float. Now the formula for slack is L minus E. Now as we had discussed earlier, the slack for any event which is critical, will always be 0. So you need to observe all the events which have a slack or float of 0. So if you observe, the first event has a slack of 0, 0 minus 0. The third event has a slack of 0, 3 minus 3. The fourth event has a slack of 0. The fifth event has a slack of 0. The seventh event has a slack of 0. So if you join all these events, you will get the critical path. Now I will illustrate another example for determining critical path. So the first step is calculating the value of E. E for the first event is 0. E for the second event is 0 plus 5, that is 5. E for the third event is 4 plus 0, 4. E for the fifth event is 5 plus 4, that is 9. Now if you observe the sixth event, it's a merging event. You need to take the bigger value, max. 8 plus 4 is 12. 9 plus 1 is 10, so we'll take 12. For the fourth event, 7 plus 5 is 12. 7 plus 4 is 11. We'll take 12. For the fifth event, 8 plus 12, that is 20. For the seventh event, 11 plus 12, 23. 9 plus 1, 10. So we'll take 23. For the eighth event, 23 plus 1, 34. 20 plus 1, 21. So we'll take 34. Now we'll calculate the value of L using backward pass. So E and L for the final event is going to be the same. So 34. 34 minus 11 is going to give you 23. 34 minus 1 will give you 33. 33 minus 8 will give you 25. For the sixth event, L is 23 minus 11, 13, 12. So now L for the fifth will be either 12 minus 1, that is 11, or 23 minus 1, that is 22. So you need to take the smaller value, 11. Now third event have 3 bursting events, 3 bursting activities. 25 minus 7 will give you 18. 12 minus 8 will give you 4. 11 minus 5 will give you 6. So 4 is the smallest value, 4. 25 minus 7, 18. Now 18 minus 5 will give you 13, and 4 minus 4 will give you 0. Always you need to know that for the first event the E and the L value should be 0. So if you're not getting a 0 for this, you're doing something wrong. For any given project, there are 4 kinds of float, named as total float, safety float, free float, and independent float. So you can calculate the float value for any of the activities. For that, the formulas are: total float is LFT minus duration minus EST. The value for safety float is LFT minus duration minus LST. Formula for free float is EFT minus duration minus EST, and the formula for independent float is EFT minus duration minus LST. To understand each of the float, go through the definitions.